We're going to start this Unit 6 radical expressions review by simplifying the following radical expressions. Here we have question 1 on the page. It's the second root, that's an invisible index 2, second root of 512. In order to take the root of 512, we can start breaking it down into pieces. We may not know exactly what goes into 512 twice, but we can break it down one step at a time. So I know 512 is even, so it must have the number 2 inside of it. And if I divide 512 by 2, I get 256. So it's got a 2 and a 256 inside. We can go ahead and break the 256 down into pieces as well. 256 is 2 times 128. And if I wanted to go ahead and take another stab at guessing, 128 is 2 times 64. And we can continue breaking 64 down because it's also even, but I also know that 64 is 8 times 8, so I can break it down that way instead. Because all we're doing here is looking for pairs of factors. So once I've broken this number down, I can see that I've got a pair of 8s right here. I also have a pair of 2s right here, and this 2 is the only one that would be left over that wouldn't be able to fit into a pair, which means I can bring this 2 to the front. I can also bring this 8 to the front, and the only thing left inside the radical would be the number 2. And when I simplify 2 times 8 on the outside, I get 16, and the square root of 2. And the very last thing this problem wanted me to do was indicate all possible signs for each answer. If I take a second root, my answer could either be positive or negative. And if I need to indicate all those possible signs, I need to show that with a plus or minus in front. Go ahead and take a look at the next example. In the next example, we need to do the cube root of negative 162. So the very first trick that I showed you guys is that if I have a negative inside of an odd root, the negative can be represented by the factor negative 1, which is a perfect cube, it's a perfect fifth, it's a perfect seventh, it's a perfect odd power. Negative 1 times itself an odd number of times is always just negative 1, which means this negative can come right to the front immediately. So this is the negative cube root of 162. Now all I have to do is break down the number 162. Again, I may not know exactly what factors are in there, but I know it's an even number, so it has 2, and it's 2 times 81. The number 81 can be broken down into number 9 and 9, but I can't stop here because my index is 3, so I need 3 of the same factor. So I need to continue breaking these down. So 9 is 3 times 3, this 9 is also 3 times 3, and now if I'm looking for a set of 3, I have 3 3's right here, so I can bring a 3 to the front along with the negative that I already had. But stuck inside I have this 2 and this 3. So inside my cube root, I'm still going to have the number 6. 2 times 3 left inside, which gives me the number 6. For this problem, because I could bring a negative out, my answer is negative. Odd roots only have one solution, and whatever sign we get is the sign of our answer. Let's try the fourth root of 48m to the fifth. We're going to start by breaking our 48 into pieces. This is the fourth root, so I need 4 of the same piece to bring anything out here. So I know that 48 is 4 times 12. You can break it down into whatever factors you want. Eventually you'll find the same numbers. 4 is 2 times 2, 12 is 4 times 3, and this 4 is also 2 times 2. If I want to take the fourth root, I need 4 of the same factor, and I've got 4 2's right here, and then I've got this 3 that I can't bring out. So I'm going to be able to bring a 2 out from this group, and the fourth root, and I'm going to have a 3 left over inside. I also haven't dealt with the m to the 5th power yet, so we're going to have to get back in there and take a look at that m to the 5th power. If we use the division process for this guy, I have 5 m's inside my radical. I need to break them down into groups of 4, or into 4 groups rather. 4 goes into 5 one time, so that 1 that I just wrote down is how many m's will be able to come out of my radical. The remainder here would be 1. That 1 represents how many would be left inside my radical. So my final answer would have the 2 from before, and I'd be able to bring out 1 m. And then I would have the fourth root that I had before, I would have the 3 that I had before, and this time I would have 1 m left inside my radical. So 2m and the fourth root of 3m. Now a couple things should happen here. First and foremost, I just took an even root and I got m to the first power as an answer on the outside. So every time I have an even root, an even index, and a variable to an odd power, I should put an absolute value around it. The last thing is to indicate all possible signs for my answer. Technically, if I use the absolute value, it means that I only want all the positive answers for this problem because there was no sign indicated in the original problem. However, we do want to indicate all possible signs for our answer, so I don't technically need to use the absolute value here because if I'm indicating all possible signs, my possible signs are a positive answer, which I show here with the absolute value, but I could also possibly have a negative. So I could also use the plus or minus there to show all the possible answers, positive or negative. All right. We've got example 4 here, the cube root of negative 16, a cubed, b to the 8th power. Again, I have an odd index and I have a negative inside, so I'm going to bring the negative to the front, the negative cube root of 16 a cubed b to the 8th. I'll break down my 16 into pieces. 16 is 2 times 8, 8 is 2 times 4, and 4 is 2 times 2. So I need 3 of something to bring it out of this radical. I've got 3 2's right here and 1 left inside my radical. So I'm going to go ahead and start building my new radical. I'm not going to finish it so we can see where the variables will fit in. So I already had a negative from my original problem, and I just brought a 2 out to the outside, and I'm going to leave a little bit of space to see what else can come out. And then I've got my cube root, and I already know that I'm going to have 1 2 left inside, and we'll leave a little space there to see what else is left inside. So let's go ahead and move on to our variables. I have the variable a here, a cubed. That's a to the 3rd power. I need 3 to take something out of this radical. I can go ahead and bring a out directly. If we use the long division, I have 3 a's inside. I need a group of 3 to bring anything out. 3 goes into itself 1 time with a remainder of 0. So 1a can come out and nothing's left inside. So that a will just move right to the front. Then we can work on the b's. For the b's, I have 8 of them, 8 b's inside my radical. I need 3 to be able to bring something out of my radical. 3 goes into 8 2 times. 2 times 3 is 6, so I would have a remainder of 2. So 2 b's can come out, and 2 are going to be left inside. So b squared can come out, and b squared will be left inside. Last but not least is to indicate all the possible signs for this answer, but because it's an odd root, the only possible sign it has is the one that came with the answer, which is a negative. So that one's all finished. Got a couple more to look at here. Let's go ahead and take a look at example 5. I'd like to simplify this radical expression. It's written as an exponential function, so I should rewrite it in radical form. 6 to the 3/2 power. The numerator 3 tells me what 6 is being raised to, and the 2 tells me what 6 is being rooted to. That's the denominator, that's the index. So this is the 2nd root of 6 cubed. And I can simplify this. There are a couple of ways. One of them is to actually write out what 6 cubed is, and I don't mean actually multiply 6 by itself 3 times, but to write out 6 times 6 times 6. That's 6 cubed. Because I have 6 times itself 3 times, and I only need a set of 2 to take something out of this radical, that means that I can bring a 6 to the front and have 1 6 left inside. The other way to take a look at that is because 6 is being raised to a power, it's almost like one of our variables raised to a power. I can use division with that one as well. I have 3 6's inside. I only need 2 of them to make a group. 2 goes into 3 1 time. That's the one I can bring to the front. And I would have a remainder of 1. That's the one that's left inside. Either way, I'm good to go there. Very last thing to do is indicate all possible signs for my answer. Because I just took a 2nd root, square root, I can have a positive or a negative in front of my solution. There we go. All right, we've got one last example here, which is 144 to the negative 1/2 power. We learned about negative exponents in 6.4, but we do still want to simplify this radical using the rule that we learned then. So the very first thing we can do is rewrite this without a negative exponent. A negative exponent, this negative symbol right here, means that this number should be a fraction. So I'm going to rewrite this, and my negative symbol is going to become the fraction bar. Whatever base I had, in this case 144, that will go to the other side of my fraction. And my exponent, 1/2, will go down there with it. So I have 144 to the 1/2 power. There's nothing left in my numerator, so we're going to put a placeholder of 1. So I used my negative exponent to turn this into a fraction. It's not actually a negative number at all, it's just a fraction. Now that I have the 144 to the 1/2 in the denominator, I can rewrite that in radical form, which is 1 over 144 to the first power, that's the numerator 1, the first power, and the second root, which is the square root. Now all I have to do is simplify the square root of 144. I could start breaking it up into pieces until I find factors that go in twice, but I know those factors are 12 and 12, which means that this is just 1 over 12. And that's it for this guy. We're going to go ahead and pick up with question 7 in the next video.